Good morning, everyone. So my name is Serge, and I'll walk you through the Geomagic Design X 2020 new features. So the first thing is we're going to have a look at some unroll functions and roll functions for modeling up parts in Design X and how we can work around with meshes. We'll also look at some of the hybrid surfacing workflows and some of the tools that you can use for casting, for medical applications, and just looking at accelerating your productivity in the CAD, and also reuse those tools for different applications. We'll also review some of the new framework features. So you'll be able to preview maintenance on parts. And then finally, we'll also look at additional enhancements. So the first thing is we're going to have a look at surfacing, the meshing tools, and unroll. So the selective surfacing, the new surfacing workflows reduces the modeling time for parts with both organic and prismatic features. And then we can also do reverse engineering scans of hybrid designs. So as you can see on the right, we can do casting, we can do medical, sort of bones, and we can also do just optimize the parts, such as doing optimizing the parts. So the first thing is curves. So we can extract curves from the model. So in this picture, you can see that we're method provides user more fine control over resulting surface trimming results. So we can select certain points. So I'll show you that in the next slide. So here we have a scan, and that's already a mesh. And we're just going to take the line on the outer edge, as you can see, just selected. We can then choose how much of the smoothness we want the line to be, so how much we want it to follow the curvature. So you can select between min and max, and then we can extract those contour lines. There we are. So as we can see, it's extracted the lines around the model and created the boundaries. So the next thing, we can do auto surface. So we can choose between mechanical or organic at this point. We can select the type of surfacing that we want to achieve. So do we want it to fill holes? Do we want it to be just around the mesh curves? So we don't want it to fill holes because this one's got 2 holes through. We can then select which parts we want to mesh from the lines that we've created. So you can then continue going on further and select more lines. So as we can see, we've got that one selected out. So we can now see through the model. So you can extend the boundaries. So if you don't want to be down to 0 millimeters, you can change that and add more boundaries. So we'll just do that. Okay, there we are. So we've added more boundaries. So you can see that it's moved the surface. So you can see the outer layer, and then you got 10 millimeters between the line up to the mesh top there. So if you wanted to, we can fill the holes in, so we don't end up with a patch. So you can do curvature, you can do tangent or flat. Similar tools are available to the sister software wrap. So if we just apply that. There we are. So we now have a full auto surfaced model. for that section. As you can see, it's been filled in flat. So we can go back to the previous stage if we want to change some of the settings. So we don't want to fill holes this time. So perhaps we want to select a different part of the model where the lines have been extracted. So another curve. So we've now got two curves selected. So we can then select more curves if we wish. So once we extract those, we can have a look at the bottom one now. So that's also been taken. And then we can 3D view the mesh itself. So once we're happy with the auto surfacing, we can then check how the grid patch that's been auto surfaced looks like. So this is done with the mechanical setting. The organic one would look much more busier than the mechanical one. So we can see that the circles have been drawn out with the auto surfacing. So on the left, we've got your tree, just as standard as before. And then we can preview what the surface looks like, what the mesh looks like, turn on the surface and bodies. So we can then go ahead and play around with the patch grid work. We can change it, we can add more to it. We can also look at the scanning data, so how the scans look, each individual scans before. So we can put in the planes. So do surface primitives. So we can then use the Revolution wizard to make up the model. Resize it. We can then insert and solidify the model. So there we are. So we've extruded that circle and made it revolve to be more accurate. And we've taken the flat surfaces and filled in the holes to be flat on both top and bottom of the model. And then we can review the model. So we can see there the curves and the lines where it's been followed. So the last thing, we could go into 3D Sketch and we can do some projection tools of the lines. So see how the lines have been followed. We can create an offset of the lines. So if we want to take the lines further in or out of the model, if we're not happy with where they are. So we can trim the surfaces and we can move the line to be in a different position. There we are. So that's the offsetting tool and just recreating the model back into a solid. So we can then select individual surfacing of the panels if we want. We can continue editing the part further. So as we can see there, it's matching up to the scan pretty neatly. Okay. So the next thing is to look at just selecting surfacing. So it provides users with a fast way to quick surface only the areas they want. So as before, it would select everything. You can now select individual sections of the model to surface. So let's have a look at that. So we've got a part here. I think this part has actually been topology optimized. So we'll do selective surfacing, polyfacer region. we don't want to fill in the holes. So say we want to do the inside of this hole here. So we selected the hole. Can go to the next step. So we're just selecting that section there. So reverse the polyfaces. Okay, so we're now making the outer surface of the model. And then we can extend the boundaries and smooth out the surfacing of the model. So as we can see there, we're shrinking the region depth, so just around the hole there. Okay. So then say if we want to fill in the hole, we can also do that. So we can make it out smooth, and that will not include that. So there are various ways of filling in the holes. There are various ways of creating just the outer surface on that section there. We can add, we can shrink the depth and the iterations. We can then go on to another hole. We can also look back at the scanning data as before. So we can select top and bottom, shrink the region, and then we can also go and select another section that we want to do the same to. So you can select different areas. And you can do it all in one operation. So as you can see here, we're just wanting to reverse engineer those two just the holes. We don't want to reverse engineer the entire part at this stage. So we can do that. So we're just now waiting for the process. So we filled in the holes in this part. And then we can go and take this part. And we can alter surface the holes that we've just filled in. We can then extract the contour lines. So if we want to focus on the rest of the model for reverse engineering it, we would have to create the boundaries of the lines. So now we've alter surfaced the model. So again, we can play around with these points, the patches that have been constructed. So, or we can use the fit patches, so that will fit them the best way it can. So now we can model up the model from the scanning data. So here we're cutting in through the holes, reverse engineering the part. We've optimized the surface, and the model is now ready. So the next thing is to look at an unroll function. So if you have like some something that is cylindrical, so maybe a turbine, and you can now unroll the whole scan out flat. So in the previous webinars, we have scanned tires. So what we can do now with the tires is we can check the way the tire has kept its tread by unrolling the entire scan. So here we've still got it as a cylinder, but we can add in certain points on the planes and unroll the entire rubber out flat. So we've got an unroll scan option here. So let's just we've got the plane set up and the vector. So there we are. So you can unroll your entire scan. of that tire. This doesn't have to be a tire. You can do it on something that you've created on a lathe, whether it's metal or wood. You can scan it and do the same process. So this allows us to check the tread that's left on the tire when we unroll it. So we can also take different points of the scan, draw up a 2D sketch to get the shape of the tire. So this is just another method of doing the same. So now instead of getting the curvature as we did before, we've now made the tread completely flat. So we can check for quality control how well it's been created. Or we can have it flat. And there we are. Okay, so the next thing to look at is a roll and unroll function for curves, so that you can cut through the model. So in this section, you can see that we've got a cut through a revolved part already. So what we'll do is we'll just make it flat and show you how we can add that in. So we've got a plane cutting into the part. We've got the outer lines there. Okay, so we extracted the curves from the model. So now we want it to roll around the model. So we're putting the X's and select a couple of points for where we want it to mesh around. So we've now attached the lines that we've extracted to go around the model. So if we hide the model, we can then have a look at the lines. We can merge the lines together, so to make it as one sketch. So we add points onto the model so that we can reference it. So just need to trim the line. Okay, so we're now joining the two lines together, so where the pattern matches. And then we can revolve around that insert to get the rest of the model. Okay, so now we just need to do the cut through, and we have successfully managed to model from the original scanning data, so we can see how close it is there. Okay, so the next thing is to look at separate meshes. So sometimes you'll have parts that will come in a single mesh that you've scanned. What Design X can now do is separate those parts for you individually. So as you can see here, we've got a mesh with a lot of the same object, and it's currently just as one part, but we can actually separate that into separate meshes. So different colors stand for different mesh. So you've got purple, brown, yellow, green, and so forth. So that is in the Polygons tab section tool. We also have a maintenance preview program. So users on maintenance get access to a set of tools not yet implemented in the official release. Enables limited environment scripting customization. So what that means is you can preview the part and have a look at the maintenance of it. So if I show you with a more known 3D systems part how to do that. So we've got a new feature preview, which is an add-in. And then we can choose what we want it to show. So in this case, let's do remove spikes. So we select the model, and then we're going to look at the parameters that we've set up. So iterations 10. So everything that's blue is all the spikes that we could now remove. So as you can see, if I minimize that, we can see what it will take out if we do the merge. If we did the remove spikes tool and run it now, that's what the model would look like, as opposed to what it would look like with the merge scan. So the next thing is surfacing performance. So we've got some surface fitting is faster compared to previous versions. So if you run the auto surfacing fitting tool now, it runs up to 36% faster than previously. Fit surfaces batches up to 28% faster. We've got an extracting boundary curves. So extracted boundary curves are now explicitly designated as boundary curves, which improves surfacing quality. So they've optimized the running algorithm behind the software. So the next thing I'm going to go through is just some basic tools of Geomagic Design X. So the sketch, extrusion, revolving the tool, mesh fits, and the last thing is CAD to CAD SolidWorks. So going from a scan to a solid model. So the sketching tool is very similar to as you would find in a CAD software. So if we want to sketch up a part of this, which is a scan, so we can create a mesh sketch. So we can now choose which plane we want to work with on the model based on the rotation. So we can see straight away it's outlining the sketch from the scan. We can then set off an offset of the plane and start to extrude out the model. So all the points that you see around the model, that is what has been selected for the sketch in pink, and the vector line is just the rotational axis of the model. So we need to center align the model. So then we can resize the lines from this point. So it's just drawing up the sketch, showing you how you can do the lines. So we extracted the lines from the scan, and we're now drawing up the lines ourselves for this model. So it's fairly straightforward. It's very similar to what you would do in a CAD software. The sketch tool is not much different. The only difference is that the lines have been projected for you from the scanning model. So I think I'll leave it there, and we'll move to the extrusion section. So again, the extrusion after you've done the sketch works very similar to the way you would do it in a CAD software. So once you've drawn up your sketch, So we've got an extracted of the projected lines of the scan here, and we're just creating lines into solids. So then we can extrude this part. So just quickly drawing up the lines to match the model. So then once you've joined up all the lines and they're connected, so just making sure they're tangent and match the scan. Okay, so once the lines are joined, we can then go into the extruding tool. So we're going to be extruding that top part of just the top part of the model. Okay, so we can see at the moment it's going in one direction. So we will change that. So we've got options from blind through all, up to vertex, up to region, up to the surface, or up to body. Well, at this point, we just want it to go through both directions, so mid-plane. And then we can change the size of it based on the scan. So you can specify the length. So then we can view the extrusion at the moment. So we can see at the moment we've made it 15 millimeters, which is quite thick. So we could reduce that to match more of the scanning data. So the next tool is the revolve tool, which is similar to extrusion, but works on the basis of using a axis to rotate the sketch around a model. So here we've got the 3 cylinders drawn up, and we're going to just use the revolve tool along the y-axis to get the rest of the model. So just using the base sketch that we've made on a plane, and we can now rotate the model around. Okay, so we're going to want to go 360 degrees, create the entire revolve. So we can select different parts of the model to rotate, but in this stage we want to select the longer line right in the middle of the model. Yeah, so you can customly choose how much you want to rotate the model, or you can always enter it in the angle section, how much you want to go by. Okay, so we'll click apply. And now we have a model that's been revolved. So then we can focus on the rest of the model, and we can, for the top part, as we saw previously, we would extrude that to get that part. We wouldn't revolve it, as it's a flat piece of the model. So the last thing is a mesh fit to look at. So we're just going to fit a surface onto the model to get a region. So you can stretch out the mesh fit. You can make it as large as you want it to be, and then you can rotate it around as well. So I'll just skip ahead. So once you've created your mesh fit, it will look something like this. So you can also create it via shortcuts, so you can use the tab above to create a mesh fit. And then you can preview your mesh fits that you've created. So you can have a look from two sides. We've got one created on the left, one for the right. So the one last thing is going from a scan to a SolidWorks model. It doesn't necessarily have to be a SolidWorks model, but once you've CAD'd this up from your scan using the Geomagic software, you can click SolidWorks in the Home option on the tab, which will transfer your model. So the first thing is each CAD software has its own tree package. So the tree package would have to be slightly changed for, say, between SolidWorks and Inventor. You would need to optimize the way you created the model slightly. But in this case, you can see that once we click SolidWorks, SolidWorks will open up, and then it will do a live preview video of how you created it in Geomagic Design within SolidWorks, and lay out all the tree steps that you have done. So once this is completed, you can then modify these fillets, the planes that have been created in SolidWorks, and continue CADing up the part further on in a different software. So as you can see, the model has been imported into SolidWorks successfully. So we'll just look at the live transfer updates. So 2020 has been updated for different CAD software packages that have also been updated. So SolidWorks is now supported for the 2020 version. So it's Creo, NX, Inventor, save as Katia, and you can also do Solid Edge. The new licensing system can also be, for Design X 2020, can also be used on a remote desktop support, has better security, and we've also improved the user experience so that the tools are much easier to find and locate and have an explanation on them.